Whew. All right, it looks pretty crazy up there as when you're kind of reading it out loud. And a combination of functions, I told you, this is what we're going to be dealing with, composition. And a couple things I want you to remember when we're looking at functions. Remember, a function has an input value and an output value. And when we're finding the value of a function, we plug in, what our input value is to find that value. Well, composition function, it's going to work this same way. Now we're going to have two different functions. But what's going to happen is we're actually going to have one of our functions serve as our input value. So let's look at the first one. I'm going to say a function f of x. So we have our function f of x is going to serve as a function, that means a function relationship, of another function, g of x. So that looked like that. So we have g of x and what we're going to say, rather than just saying, our function g of x, our value is going to be f of x, or the value we're going to try to find. So actually what we're going to look for is g of f of x. And that is actually what we're going to be looking into trying to find. For this one, it says I have a function g of x, which is going to serve as my input value, that is going to serve as a function relationship of another value, of another function, f of x. So I'll let you guys just kind of think of that. So this one, a function g of x as a function of another function, f of x. Just doesn't even make sense. Sounds really crazy. So pretty much what I'm really trying to tell you guys to do, actually look how they have it. So a lot of times what they write is, let me see how something like that. Okay. So a lot of times what we use in this notation is, the way that I learned it, and at least remembered it, is we called this golf. Just because it's missing, it looks like it's missing an L. This is like a multiplication symbol, but it's hollow, so it's open. But it's g of x, g of x, and then this one is f of g, and we call this one fog. It's not really an O, but it's a little circle, but I don't know, that's just the way I always remembered it. So that's exactly, a lot of times you guys will get this in your book. This is the same thing as this. So what's happening on this function is I'm plugging in my g of x function into my function of f of x. And over here, what I'm doing is I'm plugging in my function f of x into my function g of x. So let's look how this is going to work. Let's do the first one. I have g of x, which is x plus 2. So I have x plus 2. That's what g of x is. G of x equals x plus, actually, you know what? Let's just do it over here. G of x equals x plus 2. Well, if I want to find g of f of x, just like when you guys used to evaluate, when we evaluated functions at the beginning of the year, when we plugged in a number for that function, when I went and find f of 3, we plugged in 3 in for your x, right? Well, now we're not plugging in 3, but what actually we're going to do is plug in our f of x. So f of x is x squared. Now, when we look, is there anything we can simplify with? On here, there's no. So that is the final answer. Now, what we're going to do for this one is now we need to determine, we're going to plug g of x into f of x. So I first need to determine what is f of x. F of x is x squared. And now what I'm going to do is I'm going to plug g of x. So I do f of g of x into my other equation. So g of x is x plus 2. X plus 2 squared. Now for this problem, I can simplify this a little bit more. I can actually expand this out. And so, not really simplify, but just expand it out. So a little practice. Remember, x plus 2 squared is x plus 2 times x plus 2. x times x is x squared, x times 2 is 2x, x times 2 is 2x, add those together, you get 4x, 2 times 2 is 4. So that is your review or introduction to composition of functions.